Now I have good news for you. We have only 2 more cases to go and we're done with vectors for life, and these 2 are actually very easy. So what is our, I hope it's right, let me go back and check. So I think this is our, oh, it's still our 9th. So this is our 9th case, and we're in our 9th case we're going to be discussing again straight lines, but we're going to show the angle between the 2 straight lines following on vectors. So now we're going to be, as we used before, when we're talking about angles, we simply refer to our dot product rules. And that rule stated that in terms of the angle, it's cosine theta equals to a vectors A into vectors B over the magnitude product of them, or the product of their magnitudes. Now for straight lines, the only difference, or the only thing you need to know, is that A and B are the position vectors, are actually the direction vectors of these lines. In other words, in other words, when, as we said, our straight line equation is r into bt plus c, and we said that we said that this is a position vector. This is a position vector that it passes through, while this one is the direction vector. So simply speaking, if you have 2 lines, you're going to take the b of each, you're going to multiply the vectors and divide it by the product of their magnitudes, and then you're going to have a positive number, and that is going to be, it can be negative or positive. That is why you have the modulus here. You need the positive part only, and then you say theta equals to shift cosine of this number, and by that you're going to get the acute angle. Again, this is acute, and it's going to give you the acute angle between the 2 straight lines. It is this simple. If you want, I can give you a very quick example here, and in this example we are given, let me move on to another page. So in this example we're given these straight lines. So 5a, I'm just going to write it in matrix form very quick, it's easier, quicker. So you have 5, 3 minus 2 plus lambda, and here our lambda is just a parameter like t, so don't fuss about it. And then we have our second line is actually 2 minus 11, and we have an unknown a here, plus mu, which is also a parameter, it's a constant like t, like s, and here we have minus 3, minus 4, and 5. And now given that the 2 lines, so we're given that they intersect, and this is good news because that means we can equate them to each other. So first of all, they ask us to find the point of intersection. Now this is the previous case stuff, but yeah. So if we want to solve it, we're going to say 5 plus lambda, 3 minus 2 lambda, and 2 minus 2, so 2, yes, 2 lambda minus 2 is going to equals to 2 minus 3 mu, and minus 11 minus 4 mu, and a plus 5 mu. Now if we want to equate the first 2 in order to find mu and lambda, we're going to say that 5 plus lambda equals to 2 minus 3 mu, and that means that our lambda is 2 minus 3 mu over 5. So, and for the second one, we know that 3 minus 2 into this lambda, which is 2 minus 3 mu over 5, is going to equals to minus 11 minus 4 mu. This enables us to solve for mu. Let me just fetch the answer instead of doing all the algebra here. Our mu is going to equal to 2, actually negative 2, and our lambda is going to equal to 3. Now we're going to take this here and for the last one, and we're going to say 2 into lambda, which is 3, minus 2, is going to equal to a plus 5 into mu, which is minus 2, which enables us to solve for a. And when we solve for a, we're going to find that a is actually equal to 14. So yes, we found Okay, so that now that we equated them, we found A. We found also, now what we need to find is the point of intersection. And in order to find the point of intersection, we're going to simply, uh, as we said, we know that they're going to intersect, they're going to be equal to each other. It's the value that makes them equal, which is the values for u and n, and that would be going to give us 8 minus, because it's 5 plus lambda here, which is 8, and 2 minus 3 into minus 2, which is also 8. So you just replace for lambda and mu, and you're going to do it here. So for each one, this is going to actually equal to 5 plus 3, 8. This is going to be 3 minus 2 into 3, so 3 minus 6, it's going to be minus 3, and this is going to be 2 into 3, 6 minus 2, which is 4. So the coordinates of the point for part A is going to be 8 minus 3 and 4. For part B, they are asking you to find the constant A, and this is what we continued to do here just by doing the simple last part, and we got A. The part C asks you to find the acute angle between them, which is what we just learned now and what we need to actually solve for this question. This is why I gave it as an example. Now, in order to find the acute angle between them, we said that cosine theta is going to be the absolute of the product of their two direction vectors divided by the product of their magnitudes. And in order to solve this, we need to find their position vectors, which is actually given to us at the top, and we said this is the direction vector and these are the direction vectors. So we're going to multiply these two, and then we're going to multiply their product. So what we're going to do is we're going to say 1 into minus 3, which is minus 3, and then minus 2 into minus 4, which is 8, and 2 into 5, which is 10, and that would be the top part. So, and we need to add them. This is how you do it at the top. So what you're going to have is minus 3 plus 8 plus 10 at the top, and at the bottom you're going to find their magnitudes, which you can do by doing the square roots and finding it. It's going to be 3 radical 50 just to save your time, and if you do this equated to cosine theta and do shift cosine, you're going to get actually 45 degrees, and that will solve your problem. And now we can move on. I guess we have time, yes. And then we can move on in the next video to the last and final case.